Hello viewers, welcome to video number 102 of the channel MALACHEMPHILIC, and this video is the episode number 42 of Chemical Thermodynamics, and topic of this episode is some multiple choice question related to entropy. So let's see. Question number 1. The reaction A to B is not feasible, but on changing the entropy through a series of steps, that is A to C, then C to D, D to B, and they have given the values delta S A to C 50 entropy unit, delta S C to D 30 entropy unit, delta S B to D 20 entropy unit. And now the question is, the entropy change for A to B would be what? Option A 100 entropy unit, option B 60, option C minus 60, option D minus 100 entropy unit. So this is the question, and this question is based on the fact that this entropy is a state function. That means entropy change depends on initial and final state and not on the path followed. So A to B, if it goes directly, whatever be the entropy change, the same entropy change will occur if it goes via A to C, then C to D, then D to B. So now let's solve the problem. So it was given that this entropy of A to C and then C to D and D to B to D, all these things are given. Now see here, entropy change for A to C, which is nothing but which will be is equal to entropy of C final minus initial, entropy of A, and that value is given as 50 entropy unit, right? Now then, next one, this entropy change for C to D, this value, that means it will be entropy of D minus entropy of C, and this value is 30 entropy unit, right? Now if you if you add these things, then what we are getting? Look at here, this entropy at C is getting cancelled, so this is SD minus SA, that value will be 80 entropy unit, and these things will be entropy change, that is delta S final minus initial, that means it is A to D, right? Now this entropy change for B to D, that value is given, entropy change for B to D, that is equal to what it will be? SD minus SB, and this value is 20 entropy unit. Now you subtract this, that means you subtract this equation from this one. So here it is negative, here it will be positive, and here it is negative. So this value is, look at here, your SD and SD is getting cancelled. So it is SB minus SA, and that will be is equal to 80 minus 20, that means 60 plus 60, and that is your final minus initial. So entropy change for A to B. So the answer is 60 entropy unit. Let's see the option. Here 60 entropy unit means the answer B is the correct option. Right? Okay. Now we go to the next problem. Here, calculate the molar entropy change in melting of 1 gram of ice at 1 atmosphere pressure. Latent heat of fusion of ice is 1440 calorie per mole. Okay. Now let's see. The options are option A 1.226 joules, option B 12.26 joules, and then option C 1226 joules and option D 0.1226 joules. Now we have to solve this problem. So latent heat of fusion of ice, that is given in calorie. So here latent heat of fusion, latent heat of fusion, that is given as, that means that is delta HF, that is 1440 calorie, that is calorie per mole. Okay. Now 1440 calorie, but your answers, we have seen that it is given in joules. So this calorie you have to convert it into joules. How to do that? We know that universal gas constant R is equal to 2 calorie and it is also is equal to 8.314 joules. So 2 calorie is equal to 8.314 joules. Therefore, 1440 calorie, that will be is equal to 8.314 divided by 2 into 1440. Okay. Now, approximately if you do the calculation, then here it will be this 2 and 8.3, that means 4.2 we can take. Okay, this is 4.2 and then 4.2, if I approximate as 4, then it will be 4 into 1440, that means 0. 4 4 is 16, 4 4 is 16 plus 1 17, then 4 into 1 4 plus 1 5. This much of joules. Okay, this is approximately, right? Now what you have to calculate? You have to calculate the entropy change for 1 gram of ice during the melting. So delta S, that means your delta S fusion, that will be is equal to delta H fusion and divided by temperature, that is your melting point, right? Now delta H fusion approximately in joules we have calculated, that is 5760. So divided by melting point is 0 degree, that means 273, and this value, that is delta H fusion, it is given in for 1 mole, that means 18 gram. So for 1 gram it will be, you have to divide it by 18. Now what will be approximately, it will be 273, no? So this is 2 and then 2, so 2, then 21, approximately 21. Okay, so it is 21 by 18. So 21 by 18 means 1, that is 18, 3.0. So it will be say approximately 1.2 if I consider. So if I consider it as 1.2. So answer is approximately 1.2 joules. Now let's see the option. See, options are 1.226, 12.26, 1226.1226. So much difference. So easily we can say that this is the correct option. Okay. But here all these things, just I wanted to show you the calculation. Approximate value is given, but actual value, if you want to know, that is this actual value. Let me tell you the actual value. This one, this actual value is 5986.08. 5986.08. This is the exact value. That means this is the correct value. Okay. So here also it will be, you have to write how much? 5986.08. Okay. And then finally it will come as, I'll rub it off. As the answers are far from each other, so you can do the approximation, but exact calculation I am giving you. So this value is coming as your 1.2181. So 1.2181. This is joules. So this one is the entropy change. Okay. So that's why already we have take the answer. Answer is A. Problem number 3. Here, what it is? Here it is. For the given system, that is liquid water to ice. Okay. That means it is the freezing. Which of the following are correct for delta S system, delta S surrounding, delta S universe at -1 degree centigrade, 0 degree centigrade and 1 degree centigrade? Options are A, delta S system less than 0, delta S surrounding greater than 0, delta S universe greater than 0. Option B, delta S system greater than 0, delta S surrounding less than 0, delta S universe greater than 0. Option C, delta S system less than 0, surrounding greater than 0, universe is equal to 0. Option D, delta S system less than 0, delta S surrounding greater than 0, delta S universe less than 0. Right. Now, you look at here, this is the freezing. If I consider for -1 degree, -1 degree. So, at or for -1 degree, see, here I write for -1 degree centigrade. See, -1 degree centigrade, this is the spontaneous process. -1 means water will solidify to ice. Spontaneous process. Right? Spontaneous process means the total entropy change will be greater than 0. Total entropy change greater than 0, where it is? Greater than 0 only in option A and in option B. Okay. Now, liquid to solid, that means here entropy change will be negative. Okay. liquid to solid, it is releasing heat. So entropy change will be negative for the system. So here you see delta S system is negative and total will be greater than 0. That means delta S surrounding will be much greater than 0. So that delta S universe will be greater than 0. It is negative. Delta S system negative. Delta S surrounding much greater than 0. Much positive. So overall delta S universe is positive at -1 degree centigrade. So for -1 degree centigrade, the answer is your A, option A. Now coming to this 0 degree centigrade. 0 degree centigrade means this total entropy change, that is entropy change of the universe will be 0. So only one option is there, that is C. See, look at here. Here for the system, entropy change will be negative because it is releasing heat. So here system entropy change less than 0 and surrounding must be greater than 0. So overall entropy change of the universe is 0. So for 0 degree centigrade, where liquid and solid phase are in equilibrium, that means it is a reversible process. In that case, the answer will be your C. So, because total entropy will be there 0. So, here for 0 degree centigrade, your answer is your C. Now coming to 1 degree centigrade. 1 degree centigrade means it is non-spontaneous. Non-spontaneous means total entropy change less than 0. So less than 0, only one option is there, that is D. And entropy change of the system will be less than 0 because heat is released. So entropy change of the surrounding is greater than 0. It is less than 0, it is greater than 0. So overall it is less than 0. That means entropy change of the system is much less than 0. So for 1 degree centigrade, the answer will be for 1 degree centigrade, the answer will be D because it is non-spontaneous. So overall entropy change or entropy change of the universe is less than 0. Okay. So this is your question number 3. Now coming to question number 4. See here. Here, what is the question? Delta S system, delta S surrounding and delta S universe for the system liquid water to gas at 373 Kelvin. See, 373 Kelvin means 100 degrees centigrade. 100 degrees centigrade is the boiling point of water. So, the system is in the boiling point of water. Boiling point means here the liquid phase and vapor phase are in equilibrium. So, it is reversible. Okay. So, reversible means this total entropy change will be 0. System plus surrounding. Achha. Here, liquid to gas, that means system will absorb heat. So, entropy change of the system must be greater than 0. Okay. Then obviously entropy change of the surrounding will be less than 0. So that overall, okay, overall, yeah, that means it is greater than 0, less than 0, value will be same. So that overall entropy change or entropy change of the universe will be 0. So your option will be, correct answer will be C. So your correct answer here it is C. Where is C? Here. That is this one. That is delta is greater than 0. Delta is surrounding less than 0. Overall is 0. So these are the 4 multiple choice questions based on entropy. Thank you.